Okay, welcome everybody, and thank you guys for joining me. We're going to tackle a very exciting elevator problem today. So our question is, a person with a mass of 66 kilograms is standing in an elevator, and that elevator is accelerating at a rate of negative 2.24 meters per second. Assuming that the upward direction positive and the downward direction is negative, what is the contact or normal force of the elevator floor in newtons acting on this person during this period of acceleration? So you can see here, I went ahead and grabbed a nice diagram from libretext.org. As I was researching this video, I came across this diagram. I thought it really did a great job of explaining exactly what we need to be looking at. So you can see here, this diagram on the left, he's standing on a scale, but pretend that scale wasn't there, the floor of the elevator would be giving that same normal force. So the first step we're going to do is a little bit of bookkeeping, and we're going to determine our known values. So we know that our mass of our system, which is our person, is 66 kilograms. And the acceleration is negative 2.24 meters per second. And if the upward direction is positive, it means they're accelerating downward. So just based off of that, we know that our normal force should be less than when the elevator was at rest. So determine what you're trying to find. Always good to make sure you're looking for the right stuff. What is the contact / or in parentheses normal force of the elevator floor in newtons acting on this person during this period of acceleration? So the most important thing here is finding the overall acceleration that the person is experiencing. The overall acceleration is not negative 2.24 meters per second. You have to account for normal gravity. So 9.8 meters per second plus negative 2.24, we're going to get 7.56 meters per second squared. A little note here, since we assigned gravity the value of positive 9.8 meters per second, the positive acceleration means that the net acceleration is pushing our object towards your center. So that negative is reducing the acceleration that our system is experiencing towards the center. So now we got to find the actual normal force provided by the floor on the person in the elevator. Once again, our guy's on a scale, but pretend he wasn't. It would be the elevator providing that normal force. And we know that normal force is just mass times acceleration. So we have our mass of 66 kilograms, multiply it by our net acceleration, which we just found on the last slide. And that's going to give us 498.96 kilogram meters per second squared. And if you're familiar with your units, you'll understand that kilogram meters per second squared is equal to newtons. So we've just like that found our final answer, 498.96 newtons, or just about 499 newtons. And if you calculate that out, you will see that it is a lower normal force value than when the elevator was at rest, which agrees with what we had hypothesized earlier. So that is how you would solve these types of problems, and I hope this is helpful to you.